All right, folks, this is going to be a quick lesson on simplifying expressions with exponents. So if you're working on this on Khan Academy, this lesson will help you out. I've just downloaded the Cornell Notes page to try to sort of up my game a little bit. You'll notice that the topic and objective is simplifying expressions with exponents. You can just write this in on your notebook, or you can borrow one of these pages. And then my essential question is, how do I simplify expressions with exponent rules? Again, how do I simplify expressions with exponent rules? And the first big question that we are going to ask is, what rules should I remember? And please remember that at any point you can pause this video to write down or catch up with what I've written. So what rules should I remember? Rule number one is going to be power of powers. And I'm just going to give you examples here. So power of powers means that if you have an exponential expression, I'm going to change the size of my pen here. If you have an exponential expression like 2 to the third raised to the fifth power, you simplify parentheses by multiplying. I'm going to make a star here. And so this is just review. I'm not going to go into the why of this. If you're interested in the why or an explanation of why, you can ask me. But to simplify parentheses, you multiply, so that means I'm going to get 2 to the 3 times 5, which means I get 2 to the 15th, and that's how I would simplify it. All right, next rule I'm going to remember is division of exponents. And so, for example, I might have an expression like x to the fifth over x to the second. And so I simplify division with subtraction. And so this becomes x to the 5 minus 2 equals x to the third. Now it's simplified. So when you have division, you subtract the exponents. The next is multiplication of exponents. For all these, it's when you have the same base. So, for example, if I had x to the second times x to the fourth times y to the third, I can simplify multiplication, which I'm going to just put simplify multiplication with addition. Okay, so since these two have the same base, it'll become x to the 2 plus 4, and then it's still going to be y to the third because there's no same base there. This becomes x to the 6th, y to the third, and now it's simplified. And so when you have multiplication of the same base, you can add the exponents. So those are the three main rules. I'm going to talk about two other things to remember here. I'm going to write n to the 1 equals n. And the way I can put that is anything to the first power is itself. So n to the first power is n, and so for example 4 to the first power is equal to 4, and 1256 to the first power is equal to 1256. The last thing I'll note is n to the 0 equals 1. Anything to the 0 power is 1. All right, so those are the rules I need to remember. Let's go ahead and do an example. Okay, so what is an example? And so I'm going to go ahead and use this one that's over here on your screen. I can kind of zoom in a little bit, I believe, so that you can maybe see it a little bit better. So I have x to the 5th, p to the negative 4 to the 4th, and then I'll have x to the negative 3, p to the 5th to the negative 5. And so first I see parentheses, and so I'm going to simplify the parentheses with multiplication. And so I'll do 4 times 5 and 4 times negative 4. And so I'll get x to the 20th and p to the negative 16, because 4 times 5 is 20 and 4 times negative 4 is negative 16. I'll do the same thing on the bottom, so negative 5 times negative 3 and negative 5 times 5, and so that would be x to the positive 15 and then p to the negative 25. All right, so now I have division, so I'll deal with like bases. First I'll do x to the 20th minus 15, and then I'll do p to the negative 16 minus a negative 25. I want you to remember that subtracting a negative is just like adding, and so my final answer here will be x to the 5th, because that's 20 minus 15, and p to the negative 16 plus 25 is p to the 9th, because that's just 25 minus 16. And so I should be able to type that in and get it correct. And I'll just type in the exponents for these problems. Hooray! Okay, let's see if this next example is one that is helpful. It's not, but I'm going to go ahead and show you another example here that you may find useful. So let's say I have t over t to the negative 2 p to the 4th to the negative 2nd power. Okay, so first things first, I'm going to take care of the parentheses. So again, I'll multiply. The top stays the same because there's nothing to do up there yet. Negative 2 times negative 2 is t to the 4th, and negative 4 times negative 2 is p to the negative 8. Okay, so now there's two things I want to note. First is that we need to remember that fact that if you have just t by itself, it's the same as t to the first power. Okay, and so for this, I'll do 1 minus 4 for the t, so I get t to the negative 3. For the p's, there's no p on the top right now, but you can always multiply 1 and not change anything. And so what I'm going to do is I'll erase that. I'm going to multiply by the special one, p to the 0, because remember, anything to the 0 power is 1. So now I have 0 minus a negative 8, and so that would end up being p to the positive 8, which you can shortcut by thinking anything you want to move to the top has to change its sign. And so that's just two of the twists that you might run into. I'll leave it to you at this point to write a summary at the bottom of your page. You want to think about what the process is for this and what you might have to do, and summarize it as best you can. That summary is really important to write so that you can try to lay down the memory. And then please refer back to these notes when you need to.